Doesn't look like much today. Should be pretty fast. Jen's buying one notebook for $3 and several pencils that we don't know. We don't know the quantity for $2 each. Write an equation to find total cost. How much will she spend if she buys 4 pencils? Well, complete the sentence. So the total cost is going to depend on the number of pencils that she writes, right? On the pencils, plus the one notebook that she bought. Right, so that's the one thing that repeats. It's plus 3, and then what changes the number of the notebooks. So T, total cost. Now, how much is each pencil? $2. So we can write 2 times the number of pencils plus, instead of notebook, it's only one notebook, so we can write it like that. If you decide to write it like this, that's also the same thing. Okay. Now, with this, right off the bat, we have our y-intercept. And we have our slope. So let me just go over here. I'll write it on top. X, Y. Here's the rule. This is what's happening to every single x value. So let's just write 0, 1, 2, 3, 4. I'll use that. And then, sorry, for the rule is literally what's happening to my x values. Multiplied by 2 and then add 3. And then we're going to get our output, y. So 2 times 0 plus 3, we get $3. 2 times 1 plus 3, we get 5. 2 times 2 plus 3, we get 7. 2 times 3 plus 3, we get something, 9. And then 2 times 4, I'm buying 4 notebooks, and then that one pencil gives me 11. Right, so we have, and then actually I should have drawn one more column here. Where's my actual, right? And you don't have it, but that's okay. So this is 0, 3. This is 1, 5. This is 2, 7. 3, 9. 4, 11. And we can continue on and on, right? Depending on how many notebooks you buy. So this is my y-axis, which is the total cost. This is my x-axis, which is my independent, or the number of pencils. Now, how do you explain that at 0, when I buy 0 pencils, right here, I already I'm spending $3. Well, I didn't buy any notebooks, but I'm still buying that pencil, right? So let's do 1, 2, 3, 4. But let's do 1, 2, 3, 4. So, sorry, I don't want to lower the screen because that's going to mess up everything. 1, 2, 3, 4, and then up we go by. Let's go by 2. So let's make this 2. So this is 0, 2, 4, 6, 8, 10, 12. Let's plot the points. 0 notebooks, I pay $3, so it's right over here. 1 notebook, I'm going to pay $5, so it's right between 4 and 6. 2 notebooks, I'm going to pay 7, which is right here. 3 notebooks, I'm going to pay 9. And then 4 notebooks, I'm going to pay 11. And then we could have gone on and on and on, but we're not doing that. So let me draw this line. Make sure you put an arrow on it. Okay, so my line has a name, and this is called y equals 2x, right, the slope. And then my y-intercept is 3, right? This line is crossing the y-axis at 3. I think that's it. All right. All right, so let's do this one. Maybe I can get this to be a little bigger. Here we go. All right, Will makes $8 an hour. Gets paid every Friday, okay? He gets a weekly deduction, though, of $3 for not having insurance. Find his weekly paycheck works 20, 35, 40 hours. All right, so the money earned, I don't know if you want to write the paycheck. So his paycheck depends on the number of hours, right, that he works, and then also less the insurance, right? So as an equation, let's just use y. So y equals, how much does he get paid per hour? 8 times x, which represents the number of hours, minus that $3. That $3, it just happens once. I've used, I don't know what letters used, money earned, pay, total. You can also write it at 3h minus 3 or something, depending on the variable that you used. So let's use this, but we want 20, 35. Well, why don't we do 20, 35, 40? So this is my x, this is my y. My rule, right, what's happening to every x variable, it's going to be multiplied by 8 and then subtract 3. Let's do 20, 10, 20, 30, 40. Why don't we do that? Maybe 52. So it would be 8 times 10 minus 3, 20 times, 8 times 20 minus 3, 8 times 30 minus 3, 8 times 40 minus 3, and then 8 times 50 minus 3. 8 times 10 is 80, so minus 3 is 77. 160, 157, 240, 237, 320, 317, and this is 50, which is 400, minus 3, 397. Right, I'm going to have to find good numbers here. So here, let's do every 2 boxes 10. 10 hours, 20 hours, 30 hours, 40 hours, 50 hours. This is my x-axis, which represents the hours worked. This is my y-axis, or dependent. My paycheck, right? My weekly paycheck. Numbers. Let's go by, I guess we can go by 80s, right? So let's go, every 2 is 80, 80, 160, 240, 320, 400. And then our point of intersection, our points, coordinate points, 10 and 77. So it's going to be 10 and 77, which is just below, as best as I can here. I forgot 0. If he works 0 hours, this is an interesting point. So let's say he gets sick. So he would be paying $3, right, for insurance. So let's say the week, and 3 should be a little bit lower than that because that's 40, that's 20. So yeah, let's start with 0. So I should have put 0 there. So if he works 0 hours for the week, it'd be 8 times 0 minus 3. He would be at negative 3. This is where I made a mistake. So actually, maybe not. Maybe I can fix this. I can draw this. Just extend the y-axis a little bit. Right? It's still 0. And then I'm going to put negative 3 over here. So, because our y-intercept is negative 3. So, let me change colors. Right, so this line is going to cross the y-axis at negative 3. Wish I could write it a little. So let me put negative 3 here. So that's negative 3 right there. So 10 hours, he gets $77. So that's somewhere around here. 20 hours, he's going to get 157, which is just a little lower than 160. 30 hours, he gets 237, which is about there. 40 hours, he's going to get 317, which is about here. 50 hours, he's going to make $397. So now, one of the questions that could probably come up is that how do you explain that he doesn't work for the whole week, but he still owes $3, right? He's down $3, even though he didn't work. Well, maybe, and that's where insurance comes in handy, right? He got sick or got COVID, and for the whole week he didn't have to show up, but you still got to pay for the insurance, right? The insurance covers your doctor's visits, hospital visits, etc. So that's why we have insurance. So in this case, right, if it happens that he doesn't work for that week, he's going to be down $3. So here's my equation. Y equals 8x, who represents the number of hours, right? How much he gets paid, $8 times the number of hours minus the $3 in insurance. Okay, all right, nice little problem. Clear. I think it was that was it. Oh, and this. All right, so let's do these four. So let's see if we can recognize the dependent and independent variables here. Clear annotations, no clear objects. Number of hours and amount of money. So, okay, so we can write the amount of money that you make depends on the hours. So we can write the dependent is the amount of money. And then the number of hours that you work is your independent, right? Cause and effect. Growth in inches and number of years. So your growth in inches depends, so your growth depends on the number of years, which makes the growth the dependent, right? And the independent the number of years. Time searching and number of coins found. Okay, so the number of coins that you find is going to be dependent on the time you spent searching, the time searched, right? So the dependent is the number of coins, and the independent is the time you spent searching. Number of words typed and time in minutes. Okay, so your number of words that you type, number of words, it's going to depend on the time, on the minutes that you spent typing. This is the number of words, and the name independent will be the minutes. Okay. All right. Nothing earth-shattering there. Number of apple picks, number of apples picked, the total number of apple picks, and the total number of hours worked. So I'm going to say that the apples, the number of apples that you pick, will depend on the number of hours that you work, right? So the dependent is the number of apples, the total number of apples, and the independent is the number of hours. Force of the hit and the distance the ball traveled. Okay, so the distance depends on the force of the hit. So the dependent is the distance, and the independent is the force of the hit. Sorry, that should be force, F-O-R-C. Let me just write it again. Force, try again, force of the hit. Couple cups of lemonade and the number of lemons. Well, the number of cups of lemonade depends on the lemons, the number of lemons that you use. So the dependent would be the cups of lemonade, and the independent would be the number of lemons. Last one, level vocabulary and the number of books read. I think your level of vocabulary, vocab, will depend on the number of books you read. So the dependent is your level of vocabulary, and the independent is the number of books that you read. Okay. I think that was the first one, and then the second one, just a couple of questions, right? 4 questions. Oops, sorry. All right, no big deal. Let's see. Buys an app. April wants to buy an iPad. Let me put it right over here. She wants to buy an iPad that costs $350. She already has $90 saved. She plans to save $65 every month. Write an equation that shows how much money she has saved after n month and how many months can she buy the iPad. So the money she has saved depends on what? Depends on total, the money she has saved depends on her, what do you call it, their monthly deposit, I guess you want to call it. Monthly savings, monthly deposits, deposit plus the 90 she already has. So as an equation, right, the total, the output, the dependent, which is M, right, it depends on, and how much is she depositing every month? $65. Let me use another variable here. Let me write total over here because then we have 2M. So the total that she has in her pocket, right, towards the total is going to be 65 times the number of months every month she puts in, 65 plus the 90 that she already has. So that's what our equation. So y equals 65x plus 90. Right? So again, let me write rule. It's my x, this is my y. Let's see, let's do so let's do 1, 2, 3. Let's do, you know what? Let's skip around. Let's do 2, 4, 6. Let's do 2 months. 2 months, 4 months, 6, 8, 6 months, 8 months. So the rule would be 65 times 2 plus 90. Sorry, 65 times the month times x plus 90. So if you think about it, $65 per month in 2 months would be 65 times 2 plus 90. 65 times 4 plus 90. 65 times 6 plus 90. 65 times 8 plus 90. So after 2 months, you would have $130 plus 90, which would be $220. 65 times 4 would be $260. 260 plus 90 would be $330. Sorry. 260 plus 90 would be $350. And then we have 65. So after 6 months, plus 90, which would be 480. 130. And then 65 times 8, which is 520, and then we add 90 to it, it'd be 610. So actually, you know, her iPass got 350. We didn't need to go, well, I didn't know. So we didn't need to go 6 to 8 months. We could have done 0, 1, 2, 3, 4. So let me use, okay, so I'm going to, first of all, let's label things. This is my Y. This is saved. Right, let's call this the money she has saved. And then my x-axis, let me just extend that. It's going to be the number of months. Now, let's do, well, the number of months we can do, that's 0, right? Let's do it by 1, 2, 3. We can do 1, 2. So I made every 2 squares 1 month, and we can go up to 5. Going up and down, 2 months is going to be 220. So let's make this 200. 150. Well, let's make it 200. So every 2 is 200, right? Or every 1 is 100, same thing. We're just going to have to be really, really good at. So 1 month, right, which I didn't calculate, and I'll calculate here. 1 month would be 65 times 2, sorry, times 1, plus 90, which is going to give us 155. So 1 month is 155. That's 100, right? So let me just put that in. 300. That's 100. 155 would be about here. Right, a little bit. I mean, we can't be. 0 months. Well, at 0 months, right, she's already have some money in her bank account. Right, so this is definitely, there's a y-intercept. It's not proportional. At 0 months, she'd be right here under 100. 1 month, she would have 155. 2 months, it says here 220. It's 200, 250, 220 right here. 3 months. Did we do 3 months? No, let's do it now. So it'd be 65 times 3 plus 90. So 65 plus 3 times, no, 65 times 3 plus 90. That's going to give us 285. That's 285. So 3 months be 285, which is about right here. 4 months we have, which would be 350, which is right here. Right, we can create a line. Right, extend that line. And this is y equals $65 per month. X represents a month plus the $90 she already had in her account or piggy bank. All right, so in how many months can she buy the iPad? Well, obviously, here's our answer. In 4 months, she could have her iPad. Right, so another way of finding this is we had our equation, y equals 65x plus 90. So 350 represents the total. We could have just come over here, substitute that, and solve for x. Right, so we do minus 90 on both sides. That goes away. 350 minus 90 is 260. And then equals 65x, and divide both sides by 65. And we get that x equals 4, right? Which we already knew anyway. So you could have used that. Okay. Yeah, that's it. Little simpler one. So Sam walks dogs. She gets $8 an hour. Trust me, they get a lot more than that. Clear objects. Write an equation to find how much she makes an hour. So total that she makes depends on the hours, right? So the total T depends on the hours. So what is it per hour? It's 8H. So there's a proportional relationship. So this one is pretty easy, right? 1 hour, $8, 2 hours, 16, and so on, so on. So let's put some number 1, 2, 3, 4. The rule here is we multiply every x value times 8, right? Here's my rule, 8x. So 8 times 0, 8 times 1, 8 times 2, 8 times 3, 8 times 4. 0 hours, $0. 1 hour, $8. 2 hours, 16. 3 hours, 24. 4 hours, 32, and so forth. So this one's pretty straightforward, right? So here is the total. It's my y, my x, and the line. X is the number of hours that she works. Just gotta make this. So here we're gonna go by 1, 2, 3, and I don't have room at the bottom, so I should actually put them at the bottom. Going up and down, we're gonna go by 8s. 8, 16, 24, 32. Change colors, so 1 hour, $8, 2 hours, 16, 3 hours, 24, 4 hours, 32, definitely proportional. Go through the origin, and it's a straight line. All right, so not much to talk about there. Is that it? No, there's more. Okay, so what can this be? All right. Michael plans to walk from New York to California. Oh my God. He thinks he can walk 25 miles per day. Oof. That's 6 hours of walking. 5 out of 6? Jeez. Write an equation that shows the distance traveled after D days. How long will it take him to get to California? So, 25 hours, 25 miles per day. So the distance that he is going to walk depends on the number of days. I guess I'll use D. Hang on a second. Distance travels. Instead of distance, guys, I'm going to write total, okay? I know it says distance, only because I don't want to use 2Ds. And that depends on the number of days. So every day he wants to walk 25. So it depends on the number of days. Right, let's assume that he always walks 25 miles per day. So my equation would be t equals 25 miles per however many days, or y equals 25x. The rule here, we're going to multiply every x value by 25, so it's 25x, 25 times x. So, the distance is 20. How long would it take to get to California? How should we do this? Let's just represent this scenario. Let's do, we can do by 10. It's not going to be enough, but let's just do by 10. So 0 times, so 25 times 0, obviously it doesn't work any day. It doesn't. That's just 0. 25 times 10 days would be 250 miles. 25 times 20 days, that'd be 500 miles. 25 times 30 days would be 750 miles. And 25 times 40 days, at 40 days he'd be at 1,000 miles. Oof. All right, so let's graph this. My y. Now this is the distance in miles. This is the number of days he's been walking. We're going to do this by tens on the x-axis. Going up and down, we can go by 250. So let's go by 250. 250. 500. So every 2 boxes is, so that's 1,000. So proportional. 10 days he walked 250, 500. Let me change colors. These are my points. 30 days he's at 750 miles. 40 days he's at 1,000 miles. 50 days he's going to be at 1,250. 1250 over here, and so forth and so forth. We haven't answered the question, but let me just graph this relationship first. All right, so we're looking for a point, and allow me please to erase this. All right, so if we looked at the graph, right, that's what's that, 750. This is 1,000. This is 1,250. So we actually want this 2,000, right? So at this point over here, when he travels 2,000, walks 2,950 miles, what would be the number of days? So again, let's imagine that was a point which is on the line. Remember, it has to be on the line. Right, so we know that y value. So that point over there is this point over here. Coordinate-wise, this is 2,950, which is my y value, and they're asking for the x value, right? That's what they're. So that's what's missing right now. So we put this right on the graph. We can see the relationship. So how can we use the equation? Well, the equation was what was the equation? Y equals 25x, right? Very nice and simple equation. Now let me just write it over here. We have a point here, a coordinate point. Coordinate. Well, we have the y, but we don't have the x. Oops. Can I come over here and somehow use my equation to figure out what x is? So this is what's missing, right? This is x and this is y. Here's my equation. My equation has 2 variables. I know one of the variables. I know what y is, 2,950. I need to find what the x is. Well, let's use that to our advantage. So y, let's replace that with 2,950. So if he walks a total distance of 2,950 miles, how many days would that be? Well, every day is 25 miles. And we're going to divide this by 25 and this by 25. So x, the number of days, would be 2,950 divided by 25 would be 118 days. So this point over here, where y is where the distance, the total distance traveled was 2,950, matches is how many days? It's 118. So that is 118 days walked to get to 2,950. Last one, really. Okay, Netflix. Yeah, they just raised prices. So this is completely. Netflix is starting a new plan. Members will now pay a fee of $4 per month and also pay $50 per movie watched. Write an equation to show the total cost when watching M movies. How many movies can you watch with $10? All right, so this is probably a long time ago. I don't think you guys were born when Netflix. You couldn't see it. You actually selected CDs. They would send CDs to your house. I don't think when they began, you couldn't watch it online. Yeah, they were not streaming. I'm pretty sure they remember CDs. My God. And before that, we had Blockbusters. Jeez, pretty sure. I don't think any of you experienced Blockbusters. Blockbuster. Oh my God, sorry. So Netflix. What do we want here? How many movies can you watch with $10? Well, let's come up with the relationship here. Clear objects. All right. Write an equation to the total cost when watching M movies. So the cost. Let me write total cost. It's going to depend on per month, right? Total cost per month. So I should write total cost per month. It's going to depend on the movies, the number of movies that you watched. The movies watched plus your $4 fee. Okay, so this is actually, I'm missing a word. I should have said, right, you could show the total cost when watching M movies per month. So Y in this case, right, the total cost is going to be 50 cents per movie plus that $4 fee. Okay. X and Y, in this case, our rule is multiply the number of movies that we watch times 50. I should write X, and then we can add our monthly fee. So if you watched, let's just go 1, 2, 3, 4. You watch 0 movies, right? And that can happen. You have a very busy month at work. So if you watch 0 movies, 50 cents times 0, so you don't have to pay. You still pay the $4 monthly fee. So it's like going to the gym and never going to the gym. Actually, it's having a gym membership and never going to the gym. Very common. You still have to pay for it, right? So 0 movies, you still pay $4 of your monthly fee. So if you watch 1 movie, well, it's 50 cents times 1 plus that's $4 monthly fee. You would pay $4, $4.50. If you watch 2 movies, 50 cents times 2, which is obviously $1, plus 4, you would pay Netflix $5. 3 movies, 50 cents times 3. So that would be $1.50, $5.50. If you watch 4 movies, pay $2 plus 4, which gives you 6. And then, well, do I have room for 1? Let's just do 1. 5. 50 cents times 5, which is $2.50 plus 4. You would end up paying Netflix $6.50. Well, let's graph this. Okay, this is number of movies. My x-axis, this is my y-axis, this is the total that you pay, total paid. I'll change colors. So let's 0. You know what, I'm going to have to do 2, 3, 4, 5, 6, 7, 8, 9, number of movies, 10 movies that I watch. And then over here, let's go by 4s. So every box is 4. 8, 12, 16, 20. Really? Wait. It's not. Sorry, 4 is too much. Let's go by 2s. Yeah, let's go by 2s. Sorry, 4 was too much. 2, 4, 6, 2, 4, 6, 8, 10. And again, could have used 2, 4, 6, 8, and then I'm going to make one more line here. Erase that 6, 8, and then I'll add one more line. Okay, and that'll be my 10. This is the total cost, my y, right? The total. So this is the total that I spent, and then at the bottom is the number of movies that I watch. Okay. So if I 2, 4, 6, 8. If I watch 0 movies, guess what? I still have to pay Netflix $4, and that's why the graph starts there, right? This line starts at 0, 4 instead of 0, 0, because at 0 I still pay Netflix something. So one movie I pay $4.50. That's easy. $2 I'm going to pay, 2 movies I'm going to pay $5. 3 is going to be here. 4, I'm going to pay $6. 5, $6.50. 6 is 7. 7 is here. 8 is 8. 9 is going to be that back. Remember, 5 is 650. 5 is 650. 6 is going to be 7. 7 is going to be 750. That's better. 8 times 5 is going to be 40. So that's 8. 9 is going to be 850. And 10 is going to be $9. Well, it's going to be, and then I'll just add 2 more, 11 and 12. 11 movies is $5.50, so that's going to take us to $9.50. And then 12 is 6. And that's our answer, right? So when I spend $10, I can actually watch 12 movies. Not the preferred way of doing this. What you can actually do is go back to the equation. Y equals 0.50 per movie plus the $4 monthly fee, and we can just substitute. So if you had $10, how many movies can you watch? Well, they're saying, this is what they're saying right now, that your Y value, Y, which represents the total, what happens when you spend $10? How many, number of movies? How many movies did you watch? Well, now that I have that, I can simply substitute Y for 10, and then I'm going to subtract 4 from each side. 10 minus 4 is 6, 0.50 m. I'm going to divide both sides by 0.50 or 0.5. How many times can 50 cents go into 6? 12. So the number of movies I can watch would be 12. So the visual, could have done visually, or you can just do it in the equation. So here, 0.1210, which is this point that we found using the graph. What time is it? It is still 4:57. You still have a couple hours to do the $3 product sum question if you want to.